Hi everyone, welcome back to our channel. Today we are going to solve this problem number 10 on coupled coils. The given problem is write the KVL equations for the given 3-winding transformer. This is very important. Okay, so if you are able to write this KVL equation, then you can solve any category of problem which are mutually coupled. So here you can see that basically we are having 3 windings. This is called as primary winding of the transformer. This is called secondary winding of the transformer. This is called tertiary winding of the transformer. They have a mutual inductance of L henries. Okay, so L henry means L will be given in henry, but they are already transformed into ohms. This I can write on it as plus J XL ohms. Okay, the units of XL is omega L. This I can write on it as plus J omega L1 ohms. This is given in the problem. So the problem framer has given the problem exactly to make us very simply write down the equations. Okay, so directly has been converted the given henry to ohms. Let's try to write down for this. Okay, so here we have through 3 inductors, therefore we will get 3 KVLs. Okay, let's try to apply for this loop. Okay, primary. So try to apply Kirchhoff's voltage law for the loop 1 or for the mesh 1. Okay, so here voltage source. What is the voltage source we are applying is V1. Okay, V1 is the applied voltage is equal to voltage source is equal to voltage drop. So first drop is due to the inductor. So where how to write down the voltage is equal to V is equal to I into R. So what is the current in this inductor is I1 into R. What is the R value? It is nothing but plus J omega L1 ohms. So with this self-inductance is completed, but this inductor 1 is connected with inductor 2 with the mutual inductance of plus J M12. Okay, and you can see here. So how to mark the polarities of mutual inductance? So current I1 is entering the dot. Current I2 is also entering the dot. So dots are there at the entering of the coil. Therefore, I can say that mutual inductance is also positive. Okay, so therefore you are going to get plus. So mutual inductance on the first coil is due to the another coil. What is the current in the another branch? I can write down this as I2 into what is the mutual inductance value? Plus J omega M12 ohms. Okay, so here you can see here dot indicates starting of a winding. What is the importance of dot in electrical engineering? Is dot indicates this is the starting of an winding. Where the winding has been started will be indicated with the help of dots. That's the meaning of dot. Here current is entering the dot. Here also current is entering the dot. That's why you got the MS positive. Okay. Now this coil 1 is linked with coil 2, but coil 1 is also linked with coil 3 with this value. But here coming to the polarity, current I1 is entering the dot, but current I3 is leaving the dot. Therefore, you are going to get a minus, and this mutual inductance of the first coil is due to current in the third coil. Okay, mutual is general. Mutual means another person. Okay, so in first KVL equation, we are getting the current I2. Why? Because this is the current due to another coil. So this is the current due to another coil affecting first coil. I2 is the current affecting first coil. I3 is the current affecting another coil. Therefore, in the mutual, you will get only other currents. Okay, so here how to write down is I into R. So here what is the current in this coil is I3. Okay, the current I3 into resistance is how much? Plus J omega L3, sorry, so I have to write down it as it is plus J omega M13 ohms. Okay, so this how to write down. So now successfully we had written this will act as a self inductance, this will act as a mutual inductance, this will be acting as an another mutual inductance. This mutual inductance I am labeling as coil 1 due to second coil, coil 1 due to third coil. Successfully we completed part 1. So now similarly let us try to apply KVL for the second loop. Apply Kirchhoff's voltage law for loop 2, I mean second loop. So we have to write down the formula V is equal to I into R. So what is the voltage source we are applying is V2. Okay. What is the drop due to self inductance? Okay. So here I can write down it as I2 into R. What is the R value we are getting here? Plus J omega L2 ohms. So this is nothing but plus J XL. XL is equal to omega L2. This is completed. But second coil is linked with the first coil. Okay. So this is called mutual inductance. Already I told I1 current is entering the dot. I2 current is also entering the dot. Automatically you are going to get positive polarity. And the mutual, what is the I2 is the current of the one coil. I1 is the current due to another coil, which is nothing but first coil. So you have to write down the current I1 multiplied with the mutual inductance is value is how much? Plus J omega M12 ohms. This is nothing but I into R. Now, but this second coil is also linked with third coil, but in which fashion it is linked is I2 current is entering the coil, I3 current is leaving the coil. Therefore, you will get the mutual inductance as minus, and this mutual inductance is always due to another current. What is the name of that current is I3 current of what is the mutual inductance we are having, which is nothing but plus J omega M second coil onto the third coil. So I can claim this V2 is the voltage source. All these are what are written right hand side are voltage drop. This is due to self inductance. This is due to mutual inductance of second coil onto the first coil. This is mutual inductance of second coil onto the third coil. This is how to write down. Okay, then you will get a clarity. Now let's try to go with the next step, which is nothing but apply Kirchhoff's voltage law for third loop, or which is nothing but for third mesh loop 3. Okay, and remember the formula V is equal to I into R. So here what is the voltage source we are applying is V3, which is nothing but voltage source is equal to drop. What is the self drop due to one inductance is I into R. So first current is how much? I3 into R. What is the R value due to self inductance, which is J omega L3 ohms, I into R. Next one, coil 3 is linked with the first coil, coil 3 is linked with the second coil. So this is mutual inductance, this is also mutual inductance. Now consider 3 on to the 1. Okay, so here current I1 is entering this coil, current I3 is leaving, therefore you are going to get minus. And I am writing for this coil, the mutual current value is I1 and the inductance value is plus J omega M13 ohms. And so 3 on 1 is completed, now 3 on 2, but these are also how they are connected, you have to think. So current is entering the coil, current is leaving the coil, therefore you are going to get minus. And what is the mutual current, which is nothing but I2 is the mutual current. And what is the amount of mutual inductance is I2 into plus J omega M23 ohms. Okay, so this is how to write down, okay, the concept of mutual inductance. Hope you are able to understand. So this is how to write down the KVL equations carefully. Very simple. When both the currents are entering, then you will get a positive mutual inductance. When one current is entering the dot, another current is leaving the dot, you will get minus. So same fashion. Okay. So coil 2 on 1. So 2 on 1 will be positive and 2 on 3 will be negative. And 3 and 1 is entering, one is leaving, therefore first minus. And one is entering, one is leaving, therefore second minus. Okay, like this you are going to get how the mutual inductance or self inductance. I can say this as very simple. This is voltage source, and all these terms are voltage drop, and this drop is called self inductance, and this drop is called mutual inductance, but mutual 1 to 3, and this is the mutual from 3 to 2, or 1 to 3, both are symmetrical in nature. Okay, hope you are able to understand the technique of explanation. So if you feel my explanation is good, please like the video and share with your friends, those who are studying these same subjects. And if you have any doubts in marking the polarities, let me know in the comment section. I will answer your doubts. And if you are watching my channel for the first time, subscribe to my channel with the name AB Prasiram. Kindly encourage this sort of free channels for the benefit of students and faculty. Okay, so this is not an entertainment channel, this is only an educational channel. That's why I'm saying better you encourage where I can make a beautiful videos for you. Thank you for watching patiently. We'll meet with then one more unsolved problem.